Welcome to the bestest, most awesomer presentation ever. Our first question is, what is sample resolution? To answer that, we'll have to go over to this handy little diagram I'm about to draw, and I'll insert a sound wave that we record through a microphone. Presto! Now we can put time on the bottom and sample resolution on the y-axis, which are also known as the levels. I'll mark each interval with its own unique bit pattern, ignoring that I drew one too many. Time is in seconds, so now we have a sound wave which is a continuous electrical signal, but we don't want that. So at the bottom, we'll choose our sample rate, where we decide how many samples we're going to take in a second. And at each sample, we'll round the wave to the nearest level. And now we can just read the bit pattern for each bar's level. Now we just converted the wave that we just recorded into binary. So using this, we can get the formula sample rate times sample resolution. Sample rate being the number of samples taken per second, and sample resolution, the number of bits used to represent each level, both multiplied by duration with the units hertz, bits, and seconds respectively, to equal the sound file size, or sample size. And that is how you turn analog sound into something a computer can understand. Now on to Nyquist's theorem. Take this standard sine wave and recall how peak to peak would be one cycle of the wave, which is equal to its wavelength. If you were to sample the wave at every one cycle, or at a frequency equal to the wave, you would just get a straight line, which isn't very good. But if you were to record it at twice the frequency of the wave, or every half cycle, you get a wave which is pretty much the same. But of course, at even higher frequencies, you would get a much better sound quality. So basically, Nyquist's theorem suggests that for lossless digitization, the sampling rate should be at least twice the maximum frequency, but having many times more is a lot better.